Hello everyone. Welcome. In this presentation, we are going to explore the state machine design process. State machines are a fundamental concept in both hardware and software design. They provide a structured way to model systems that transition between different states based on inputs. Let's dive in and learn a systematic approach to state machine design. Let's outline the main steps in the state machine design process. First, we have problem analysis, where we define the system requirements and behavior specifications. Second, we identify the states by determining all possible states and their characteristics. Third, we map the transitions by defining state transitions and triggering conditions. And finally, we implement the state machine by converting the design to a hardware or software solution. Let's begin with Step 1, Problem Analysis. This is a critical initial step in designing a state machine. During this phase, you need to thoroughly understand the system requirements and behavior specifications. Here are some key questions to consider. What are the system inputs? What are the desired outputs? What behaviors must be exhibited? And what are the constraints? For example, let's take a traffic light controller. Its inputs are timer sensors. Its outputs are red, yellow, green lights. And its behavior is a cyclic sequence with timing constraints. Moving on to Step 2, State Identification. Once you have a clear understanding of the problem, the next step is to identify all possible states of the system. Here are some identification criteria. Consider the unique system conditions, distinct output patterns, different response behaviors, and memory requirements. As an example, a traffic light has 3 states: red, yellow, and green. Step 3 is transition mapping. After identifying the states, you need to define how the system transitions from one state to another. These transitions are triggered by specific conditions or events. Here are the key elements to consider: the current state, input conditions, the next state, and output actions. Now let's consider a traffic light again. When the current state is red, the input from the timer changes the next state to green. When the current state is green, the timer changes the next state to yellow. Finally, when the current state is yellow, the timer changes the next state to red. In this step, we'll assign a unique binary code to each state. Encoding methods include binary encoding, gray code, one-hot encoding, and custom encoding. Now let's consider the binary example for a traffic light controller. State red is assigned 0, 0. State green is assigned 0, 1. State yellow is assigned 1, 0. Step 4 is implementation. With the state machine designed and the states encoded, you can now implement it in either hardware or software. Several implementation approaches are available: hardware using an FPGA or an ASIC, software using a microcontroller, digital logic circuits, and HDL description. Here is an example of a traffic light controller written in Python. We define a class traffic light. The init method initializes the state to red. The next state method defines the state transitions. If the current state is red, it changes to green. If it is green, it changes to yellow. Otherwise, it changes to red. Before concluding, let's consider some design practices and validation steps. Follow these best practices. Minimize state count, use clear state definitions, handle all input cases, and plan a reset state. Here are some validation steps: functional simulation, timing analysis, edge case testing, and performance verification. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.